All right, so this is just part 2 of connecting English with mathematics and graphing lines. We're going to take a look at a few more points of intersections, but specifically now using some word problems. Okay, so just to recap, we can find our point of intersection by graphing the following lines. So if I graph both these lines, I'm going to use my slope here, which is a -1/2, so that's my m. And then my y-intercept is at 1. So I'm going to go to 1 and put a dot. And then I'm going to go down 1 to the right 2. Down 1 to the right 2. I can even go up 1 to the left 2. Up 1 to the left 2. And then that gives me this really nice line. By putting more and more dots, following my pattern, it allows me to kind of see where the line is without having to put a line in. But I am going to put a line in, and it would look something like that. Okay, and then from here in purple, so here's my slope and here's my y-intercept. Now that slope doesn't have a run, but of course we can always put a run by putting it over 1. So let's start at -2. And I want to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And I can go in the opposite order. I can go up 2 to the left 1, up 2 to the left 1. Oh, there's my point of intersection. Up 2 to the left 1, up 2 to the left 1, and so on. And then, of course, I can draw my line right through this. There we go. And in this example, so very nice, we can see our point of intersection right here where these two cross is at -2, +2. Perfect. Okay, so that's how we can graph when we're given our two equations. But what if we're not given both equations? What can we do then? So here we have a Clark family has 2 car rental agencies, and we're given the following information. So Cool Car Company will rent them a luxury car for $5.25 per week plus 20 cents per kilometer driven. And Classy Car Company will rent the same type of car for $500 a week plus 30 cents for each kilometer driven. All right, so let's take a look at what we want to do with this. Let's start with A. Write an equation to represent the cost from the Cool Car Company. So we're going to say, this is where we're going to use our let statements. So let's say C equal cost. And let's say let K equal kilometers driven. So if we're going to do the Cool Car Company, that's this first one, my cost is equal to that 525 for the week. So 525 plus I have 20 cents per kilometer driven. Now, because it's in cents and we don't express things in terms of cents, we always use dollars. I'm going to change this 20 cents into dollars. So that's 0.20 dollars. So 0.20. And then I don't know how many kilometers I'm going to drive. So that's where that K comes in right there. That K represents the kilometers I'm going to drive. And it's 20 cents for every kilometer. So that's why those two go together right there. Okay, so then part B says, can we now write an equation for the other car company? So the Classy Car Company. So my cost, my let statements are just the same. So my cost is going to be 500 per week. So 500 per week plus 30 cents per kilometer. So I'm going to have to change that 30 cents into dollars, which is 0.30. So 0.30. And then again, the K comes at the end of that because I don't know how many kilometers I'm going to drive. So now we have our two equations. So then part C is draw a graph to find the distance for which the cost is the same as the company. What does this tell the Clarks? Okay, so when we draw our graph now, It's going to be a little bit messier because we have these decimals right here. And I just want to show you how we can quickly kind of change things up. So let's take the first one right here. So cost, I would like this in y equals mx plus b form. So I'm going to put this part first at 0.20, but that's the same thing as 20 over 100. Okay, so I'm going to get rid of the decimal and I'm going to change it to a fraction. And I know that you might not like that, but trust me, it is so much better when you go to graph it. And then I have that plus 525. And the same thing with my second equation, 0.30. I'm going to change that to 30 over 100, okay, plus 500. And the reason why I like these fractions is because now when I go to graph, I can use my rise over my run. All right. So let's just, if you don't mind, let's just go here and we're going to create a grid. So let's, I'm going to draw a line straight down and a line straight over. And I'm going to label a few things just to get us started. So this is our independent variable. This would be our kilometers driven. So that would go here. And up here, my cost is my dependent variable because my cost depends on how far I drive. Now, when we go to drive, to make this kind of easier, let me go back to the other page and look at our equations. I see that I have a run of 100. So in order to kind of accommodate that, I'm going to go here. I'm going to put this by 100. So 100, 200, 300, 400, 500, and just try to do the best that you can, 600, and so on. And then when I look at my run, I'm going to go by 20s and by 30s. And then I also see that my y-intercepts are at 525 and 500. So when I put this on my graph, I'm actually going to start with a break. And a break is, I don't want to put all those numbers that are less than 500. There's no point. Like my minimum cost is going to be $500 no matter what. That's my y-intercept. And then I have another one at 525. And then I want to go by 20s. And I have a rise of 20, another rise of 30. So I'm actually going to go, I think, up by 10s. I feel like 10s might be the best way to go here. So 510, 520, 530, 540, 550, 560, 570, 580, 590, 600, 610, 620. Let's see where that gets me. And if I have to go further, I will. But let's start with the first equation. So my first equation was 525, and then I want to go up 20 and over 10. Okay, so that's my slope, up 20 over 10, and then 525 is where I start. So 525 is right in the middle here, so 525, and I want to go up 20, so 10, 20, and then over 100. And then up 20 and over 100. And from here, I'm going to put in my line. So it looks something like this. Okay. And then for my next equation, let's go back. My next equation was 5. It's going to start at 500, and it's going to go up 30 over 100. So 500 is here. And it's going to go up 30 over 100. And then up another 30, so then I'm at 60 and over 100. And then up 30 and then over 100. Okay, I think I got it. So let's draw my nice line right through there. And then lo and behold, we have this point of intersection right here. And it looks like that happens at 200, 560. Oh, Yeah, but that's off by a little bit. It has to be because that's actually 565. So it's somewhere around there. Again, with the graphing, it gets to be such a pain because it's not exact, but that's pretty close. Maybe it's like 562. Anyways, okay. So there's our point of intersection. So it says draw the graph for which cost is it the same for both company. What does this tell the clerks? So it looks like around 200 kilometers. Cost is about the same for 200 kilometers. So what that tells the clerks then is that if they want to go more than, so if they want more than 200 kilometers, you're going to travel more than 200 kilometers, you should probably go with this second line because once we hit more than, let me just highlight this. Remember, you always want the least amount, which would be this line right there. Okay, so that would be the cheaper one if they're going to go more than 200 kilometers. And I think that was our first company. I'll have to just actually float back here. Yeah, that was that first one at, or no, second one at 525. So that was the no, that was the first one. Sorry, that was the Cool Car Company. So the Cool Car Company is the one that they want to take if they're going to go more than 200 kilometers. Take Cool Car Company. But if they were going to go less than 200 kilometers, so that would be this line's lower for less than, so less than then they should use whatever the name was of that other one. So not Cool Car Company. What was the other one? Oh, Classy Car. Okay, Classy Car Company. Classy Car Company. Okay, so that's what we like about knowing the points of intersections when you have kind of a situation going, is which like what, when do you want to choose which situation to go with? And in this case, if they're going to drive more than 200 kilometers, they want to go with the Cool Car Company. But if they were going to do less than 200 kilometers, then they would want to go with the Classy Car Company. So that's why knowing the point of intersection is so important. All right, let's try just one more here. Jill has $5,000 to invest, and she puts part of it into an account paying 5% per year in interest, and the rest into an RSP paying 7.02% interest. If she has 349 in simple interest at the end of the year, how much was invested? Okay. I know these ones seem like so complicated, and they're not too bad. I'll show you. So we have kind of two things going on here. She has, so we can say like, let A equal the 5% RSP. And then we can let B be equal to that 7.2% RSP. Okay, so when you're doing your equations for this, what's important is you want to write one equation that just represents the money. So she's going to take some amount of money. So this is the, let A represent the 5% RSP. Actually, I should put up money, like how much money she's going to put into that account and how much money she's going to put in the 7.2% account. So we know she's going to take some money A and then some money B, and all together she's going to spend $5,000. Okay, so we have like a money equation. And then our other equation is going to represent our interest equation. So our interest equation is 5% per year. Remember, we don't write it as a percent. We write it as an actual decimal. So 5% per year is going to be written as 0.05. And that'll go into RSPA. Okay. And we don't know how much that money is, so that's why there's an A there. Plus 0.072 is going to go into RSPB, so that's why there's a B there, and we know they're going to make $349. Okay, so we have our equation here now, and I know that we're using A and B's. It's a little bit different than X and Y's, but you can let any of these be X and Y. So when you go to draw your graph, so if we go to draw our graph, I can let this be A and let this be B. And if that's the case, like that's kind of X and that's Y, then I want to write these equations as either B equals, or I would say in this case, the best thing to use is our intercepts. Okay, so remember we talked about using our X and Y intercepts to graph. This is definitely where I would want to use our intercept. So taking a look at our first equation, if I let A equals 0, then I get 0 plus B equals 5,000, which means B just equals 5,000. So I'm going to put a dot up here at 5,000. And so now I'll label this 1,000, 2, 3, 4, and 5. Okay. And if I let B equal 0, then I get A plus 0 equals 5,000. So A equals 5,000. All right. And that's like the maximum amount of money that you could put in, which means they put $5,000 into one account and nothing into the other. This could be 1,000, 2, 3, 4, 5. Okay. Now, we're going to do the same thing here. We're going to use our intercepts, and I'm going to let A be 0. So when I let A be 0, I get 0.05 times 0 plus 0.072B equals 349. And I can tell that this is getting really tight. So let me just change my view. Oh, now it's really big, but that's okay. All right, let's go down here because I want to solve this and I want you to be able to see it. Okay, 0.072B is equal to 349. And I'm going to divide each side by 0.072. And B equals out to, oh, I need my calculator here. All right, 349 divided by 0.072 equals, and I get 4847.22. And if I let B be equal to 0, I get 0.05A plus 0.072B equals 349. Oops, I'm letting B be 0. So that's 0. So that's gone. So 0.05A equals 349. Divide by 0.05. Divide by 0.05. And we get 349 divided by 0.05 equals 6980. Okay, so these are my intercepts now for that second graph. So let's scroll up. So on my B-axis, I want to put this number, 4847.22. So we're going to have to approximate. 4847 is going to be like here. And on my A-axis, what was my number for A? My A-axis was almost to 7,000. So almost to 7,000. Let me go back up. Which means I'm going to have to go a little bit further. So this was 5, 6, 7,000. And we're almost right there to 7,000. Okay. So we had it right there at 5,000 and 5,000. So let me put on a couple of lines here. We have this line here. Oops. And then we have this line here. And what happens, let me just kind of change my zoom on this a little bit. So then what happens is that we end up with this point of intersection, which is like somewhere right around here. Somewhere. Okay, and we're going to have to approximate as best we can. So I feel like if I go up, I'm kind of at 2,500. And if I go over, I'm kind of somewhere around 2,200. And so that becomes my point of intersection, which means they would put 20, well, obviously this can't work out too, let me see. I'm going to fudge some numbers a little bit here. So if I put this like at 26 and I put this at 24, that kind of looks a little bit, whoops, my writing is terrible using this pen. If I went straight across. Okay, so what we're saying is in one account, they're going to put 2,600. In the other account, they'll put 2,400. And that point of intersection could make sense to us because 26 plus 24 is 5,000, right? So that gives us that $5,000. So in account A, in RSP A, we're going to put 2,600, and in RRSP B, we're going to put 2,400. And that way we would get that 349% or $349 in interest, and still have put away that whole $5,000. Now, is this the actual true answer? Probably not, because of our graph, right? Like, it looks like we're probably off by a little bit, which happens. Like, this is the problem with graphing. So as we look forward to further on in the chapter, the great thing is that I'm going to show you better ways of solving this than with graphing. Graphing is painful because we have to approximate what our answer is, and we're not getting the true answer that we want. So there has to be a better method in order to figure out these points of intersections, which I will show you as we get further along. So keep practicing, and of course, if you have any problems, come back and see me.